name is Fei. Now my crew members are going to present for the engineering practice division 20701 MPE LAB 4, and we are from session 1 group 3, and these are the team members, FATIN, CHOON, and me, Fei. Next, I will pass to my friend to continue next part.
Hi, Assalamualaikum. My name is FATIN BINTI ASROL. My metric number is AE1A0043. Hi, I will explain for my house. This one, these two MCB for my house is quite weird because this switch will control all the switch will control all the switch in the house. So if we off this, it will automatically will not light up. Okay, it will not the fan will not move because we turn off the MCB. Okay, for this one, if we turn on also, it will not light up. Okay, so the lamp will not light up. Same goes to this one. If we turn off also, all the it will control all the switch in my house. So this not suitable for the suitable for the house to install, and it's not meet the requirement for the electrical, because if we turn off this one, it will control all the switch and it automatically will turn off. The switch will not function. Also this one. Okay, then I turn on again. So I will turn on. Okay, then the lamp will light up. It will light up. Same goes to this one, the fan. I think that's all for me. Thank you.
Hi Doctor, my name is Fei, and now I'm going to show the video on the circuit tracing activity.
Hello everyone, so today I will present to you the circuit tracing for this lab. So for this lab, we need to find the locations for socket outlet and the load that connected to the MCB. For your information, the MCB1 is only connected to the socket outlet that I have been present in the previous video. So right now I will turn off the MCB for this circuit. So actually for the lighting and also for the socket outlet, we only use the MCB1, MCB2, MCB3, MCB4 and MCB5 only. So as you can see, the socket outlet for number 5 also light up. Same goes to the socket outlet number 6. So this is another socket outlet that connected to MCB number 2. So this one is for the store, toilet number 1 and also hallway. So right now I will turn it on. So this one, this light is in the hallway. So this one is in the store. So this one is in the toilet number 1. So I think that's all from me, and for the another result for the another MCB I will put in the tables. So that's all from me. Thank you.
Hello, my name is CHOON and JANIS and my matrix number is CE1L0032. So right now I will proceed to the questions in this slide. The first question is discuss the purpose of grounding in electrical wiring installations. The first purpose of grounding in electrical wiring installations is used to as a protection against electrical overload. One of the most important reasons for grounding current is to protect the equipment, the house, and the people in it from the electrical surge. If lightning strikes or spikes in current can cause dangerously high voltage in the system. When the electrical system is grounded, all the excess electricity is sent to the ground. The next purpose is to help direct electricity. When the electrical system is grounded, electricity can easily be sent where it is needed, allowing current to flow safely and efficiently into electrical system. The third one is to stabilize voltage level. A grounded electrical system makes it easy to distribute the right amount of energy to the right place. This plays a major role in preventing electrical circuit from overloading or burning out. The Earth is a common reference point for many voltage sources in the electrical system. The last one is used to prevent damage, injury, and death. Without a properly grounded electrical system, you are risking any appliances you have connected to your system. In the worst case scenario, an overload of power can even cause a fire to start, risking not just extensive property and data loss, but also physical injury as well. The next question is name 2 types of conduit that commonly used in electrical wiring. The 2 types of conduit that commonly used in electrical wiring is the first one is the rigid metal conduit RMC and RNC, and also the electrical metallic tubing or EMT. So that's all from me. Thank you.
Hi Doctor, my name is Fujun Fei, and now I'm going to continue for the conclusion part. After complete this lab, we can determine the relation between each socket and load with each MCB. After we obtain the relation between each socket and the load with each MCB, we can draw the single line diagram of our home in details. The triggering circuit result is recorded in the table. By using the result recorded in the table, we can draw the single line diagram of our homes. In conclusions, this lab has enhanced our view in drawing the single line diagram and how to determine the relation between socket, load, and MCB. Besides that, it also increased our knowledge about the power circuit and the overall power circuit in our homes. And that's all for our presentations. Thank you.